Have you ever wondered why your smartphone is so, well, stiff? A big reason for that is the battery inside. Our electronic gadgets are getting smaller, smarter, and more personal. We have watches that track our heartbeats and glasses that show us maps. We even have clothes that can monitor our health. For these amazing new technologies to work, all their parts need to be able to bend, twist, and stretch right along with us. That includes the most important part of all, the power source. A hard, blocky battery just won't work in a t-shirt that's supposed to feel comfortable. We need batteries that can move, and that means we need a whole new way of thinking about how we build and package them. Think about the battery in your phone or laptop right now. It is probably a lithium-ion battery, a real powerhouse for its size. These batteries are usually encased in a hard shell, often made of metal like aluminum or steel. This rigid case has a very important job. It protects the delicate chemistry inside from the outside world. It keeps moisture out, prevents physical damage, and contains everything safely. But this strength comes at a cost. The metal case is heavy, bulky, and completely inflexible. It dictates the shape of our devices, forcing engineers to design products around a solid, unmoving brick of power. This limitation is holding back a whole world of new, flexible electronics. The problem with these traditional rigid battery covers is that they are the exact opposite of what we need for the next generation of technology. Imagine trying to fold a credit card. It just snaps. It's the same with a standard battery. If you try to bend it, you risk breaking the internal layers, which could cause a short circuit or even a fire. This is incredibly dangerous. The hard casing prevents this, but it also means we can't create devices that conform to our bodies or other curved surfaces. We are stuck with flat, rectangular gadgets. To unlock the full potential of wearable technology, medical implants, and even soft robotics, we need to break free from the boxy battery. This is where flexible packaging comes in. It's a revolutionary idea that completely changes how we think about batteries. Instead of a hard, unyielding shell, imagine a soft, pliable pouch that can bend and flex without breaking. This new type of packaging is essential for creating flexible lithium-ion batteries. It allows the entire battery unit to be bent, twisted, or even rolled up, while still safely containing all the components inside and delivering power reliably. This shift from rigid to flexible is not just a small change, it's a fundamental leap forward. It opens the door to electronics that are truly integrated into our lives, our clothes, and even our bodies. It's science in action. So, what are these amazing new materials that allow batteries to bend? Scientists have been experimenting with special polymers, which are long chains of molecules, kind of like a string of beads. Two of the most promising stars in this field are polydimethylsiloxane, which is a mouthful so we call it PDMS, and polyamide, or PI. PDMS is a type of silicone. It's transparent, stretchy, and very durable. Think of a high-tech rubber band. Polyamide, on the other hand, is a super strong, heat-resistant plastic that can be made into incredibly thin films. These materials form the foundation of flexible battery packaging, replacing the heavy metal cases of old. What makes materials like PDMS and polyamide so special is their unique combination of properties. They are not just flexible, they are also incredibly protective. A battery's packaging has to be a great gatekeeper. It must let energy out but keep troublemakers like water and oxygen from getting in, as these can ruin the battery's chemistry. These advanced polymers are excellent at this job. They create a perfect seal around the battery's internal components, protecting them from the environment. At the same time, their molecular structure allows them to stretch and bend repeatedly without tearing or losing their shape, which is exactly what a battery in a smartwatch or a medical sensor needs to do every day. The benefits of using these flexible materials are huge. First and foremost is, of course, flexibility. This allows us to create batteries in all sorts of new shapes and sizes that can fit into devices that were previously impossible to power. Another major advantage is weight. By replacing heavy metal casings with lightweight polymers, we can make our devices significantly lighter and more comfortable to wear. This is a game changer for everything from smart clothing to portable medical monitors. And here's something really cool. These materials can often be cheaper to produce than precisely machined metal cases, which could help lower the cost of future electronics for everyone. However, creating the perfect flexible battery package is not without its challenges. It's a tough balancing act for scientists and engineers. The packaging needs to be flexible, but it also has to be strong enough to withstand punctures and impacts. It must be completely waterproof to protect the sensitive lithium chemistry inside, which is a big challenge for many polymers. Furthermore, the material must be chemically resistant, meaning it can't react with the electrolytes inside the battery, which can be quite corrosive. Researchers are working tirelessly to improve these materials, adding reinforcing layers or developing new polymer blends to create a package that is strong, safe, and super bendy. Having flexible materials is only half the battle. We also need clever designs to make the entire battery structure bendy. One popular approach is the thin film battery. Imagine making a battery like a lasagna, but with incredibly thin layers of materials deposited onto a flexible substrate, like a sheet of PI film. This creates a battery that is as thin as a piece of paper and can be easily rolled or folded. This design is perfect for applications where space is extremely limited, like in smart cards or powered medical patches that stick to your skin. It is an elegant way to make the entire battery unit inherently flexible from the ground up. Another fascinating design is the fiber-based battery. Instead of flat layers, scientists can now create batteries that are shaped like a single, long thread. You can then weave or knit these battery fibers directly into textiles. Imagine a shirt where the fabric itself is the battery, powering sensors that monitor your vital signs. This is not science fiction. It is happening right now in research labs. This approach provides ultimate flexibility and integration, making the power source completely invisible and unnoticeable to the person wearing the garment. It's a truly revolutionary way to merge electronics and textiles into one seamless system. For batteries that still use some rigid components, engineers have developed brilliant structural designs. One is the wavy or accordion structure, where the battery is built with a series of folds, like the bellows of an accordion. This allows it to stretch and compress without putting stress on the internal parts. Another is the island design. In this setup, small, rigid battery components, the islands, are connected by flexible, stretchable wires, the bridges. When the whole system is stretched, the bridges expand, keeping the islands safe from strain. These designs are inspired by nature and are incredibly effective at giving flexibility to otherwise stiff components. Finally, let's talk about paper folding, also known as origami. Yes, the ancient art of paper folding is inspiring the future of batteries. By folding thin film batteries into specific origami patterns, engineers can make them highly compact and able to unfold or stretch in complex ways. For example, a battery could be folded into a tiny square and then expand to cover a large curved surface when needed. This is particularly useful for applications like deployable power sources, for satellites in space, or for soft robots that need to change their shape to move or grasp objects. It just goes to show that great ideas in science can come from the most unexpected places. So, where can we see these amazing flexible batteries in action today? Look no further than your wrist. Many modern smartwatches and fitness trackers already use semi-flexible batteries to fit into their compact curved bodies. In the medical field, flexible batteries are powering disposable diagnostic patches that monitor glucose levels or heart rhythms for days at a time. They are also being developed for implantable devices, where their ability to conform to the shape of internal organs is crucial. Even in space exploration, lightweight, foldable solar arrays powered by flexible batteries could one day be deployed from satellites, unfurling like a flower to capture the sun's energy. The world of robotics is also being transformed by flexible power. Soft robots, which are made from pliable materials instead of metal, need batteries that can bend and stretch as they crawl, swim, or squeeze through tight spaces. Imagine a search and rescue robot that can contort its body to navigate through rubble, powered by a battery that is integrated into its very skin. Flexible batteries are the key to making these futuristic machines a reality. They provide the necessary power without compromising the robot's softness and agility, something a traditional rigid battery could never do. This allows for robots that are safer, more versatile, and better able to interact with the human world. Scientists are not stopping here. The quest for the ultimate flexible battery continues with exciting new research. One major focus is on improving the energy density, which is the amount of energy a battery can store for its size. Researchers are exploring new materials for the electrodes and electrolytes to pack more power into these thin, bendy packages. Another important area is safety. Scientists are developing self-healing polymers that can automatically repair small punctures and non-flammable electrolytes to make these batteries even safer for use in clothing and medical implants. They are also working on making them more stretchable, aiming for batteries that can stretch to double their size and snap back without losing power. Ultimately, flexible lithium-ion batteries are more than just a cool novelty. They are a critical enabling technology for the future. They will dissolve the boundaries between rigid electronics and the soft, dynamic world we live in. They will power the Internet of Things, making our environment smarter and more responsive. They will lead to medical devices that are more comfortable and effective, and wearables that are truly wearable. By freeing our devices from the constraints of a rigid box, flexible batteries will unleash a new wave of innovation, leading to technologies that we can only begin to imagine today. The future isn't just bright, it's flexible.